Hello, youth probability unit. We are going to talk about simple events, and we're going to make it that way. We're going to make it simple. So I can find the probability of a simple event. So I want you to think about, there's a lot of vocabulary in this unit, actually, for being so short. But we're going to make sense of it because probability is super common. So some vocab up there, just have a look out for that. When talking about probability, what you are talking about is the likelihood that something will happen. That's it. One way that you can think about probability and something in your real world is weather, right? We think about there's a blank % chance of raining. Well, is it likely or unlikely to rain? So this chart is going to be super helpful in determining, is it certain going to happen? Is it 100%? Is it impossible, 0%, and then in between? If it's 50% probability, that means it's as likely to happen as it is not, right? If I flip a coin, I'm going to get heads or I'm going to get tails. So I have a 50% chance of getting either one. It's likely I'm going to get a tails, and it's equally as unlikely that I'll get a tails. Anything less than 50 becomes more in the unlikely range, and then above 50 becomes more likely. So probability, this is super important that you have this little formula here. Probability of whatever given event that you want to happen, you're thinking will happen, the number of favorable times it could happen, and the number of possible. So we're going to talk about this, and it's going to make a lot more sense when we obviously give you a situation, but that formula is what we're going to use all of the time. So we're looking at the likelihood that something will happen. So when asking, what is the probability, again, the likelihood that something will happen, of rolling an even number on a number cube? Whenever you hear number cube, they're talking about a dice or a die, if there's multiple. So we have a number cube that has digits 1 through 6. Generally, on a cube, 6 faces. So the probability of rolling an even, what we're looking at, how we'd write this, is the probability of rolling an even. Because even, that's the event we're looking for. And we think about how many total possible outcomes are there. It's a 6-sided dice. There are 6 different numbers, 1 through 6. How many of those digits are even? Well, let's think about that. So we're looking for evens because that's what we want to happen. That's the favorable outcome. So 2, 4, and 6. Those are all even. So that means there are 3 favorable outcomes. So that means there's a 3 out of 6 chance, which we can simplify that. Those share a factor of 3. There is a 50% chance, it's as likely as it is not likely, to roll an even on a number cube. So if you feel ready, go ahead and give it a try. And of course, try these in real life. Find something around your house that you can do. So some simple events. Watch or pause and try on your own. Maybe watch one, try some others. Of course, believe in yourself and do your best. So we're using a number cube, a dice, okay? We want to find the probability of each situation or each event here. Remember, it's probability of whatever the event is. And we're going to write it as a fraction in simplest form. So thinking about a dice again, and now we want the probability of an odd number. Well, the probability that we're going to get an odd number, I'm thinking on my dice, that's 1, 3, or 5. Those are 3 of the possible 6 digits. So the probability is 1/2 or 50%, just like it was for even. Probability of getting a 5 or a 6. So again, I know that if I roll a dice, there are going to be 6 possible outcomes. A 5 or a 6, so the possibility of rolling either one, those are 2 of the 6 numbers. So 2 out of 6, those share a factor of 2. We can simplify to 1/3. So I have a 1/3 chance, or a 33.3 repeating % chance of rolling a 5 or a 6. It's unlikely, it's less likely than just saying odd or even. Prime number now. So we have to think about prime numbers. Think about our digits 1, 2, 3, 5, and 6. So for that event, again, I know there are 6 possible outcomes total when I roll a dice. Prime numbers are numbers that have only factors of 1 and itself. So 6 is out because 6 is 2 times 3. 5 is prime. I forgot the 4. Hello. 4 is not prime. It is composite because 2 times 2. 3 is prime. 2 is prime, just 2 and 1. Here's the tricky one, though. Is 1 prime or composite? It's neither because its only factor is itself. So that's 3 of the 6 numbers. There is a 1/2 or 50% probability of getting a prime number. Okay, so random events. I think random events just means it happens at random, right? You say, oh, that was so random. Someone said something out of the blue. So Simone and her 3 friends were deciding how to pick the song they were going to sing for their school's talent show. They decided to roll a dice. The person with the lowest number chooses the song. If her friends rolled a 6, 5, and 2, what is the probability that Simone will choose the song? Well, we have to reread the question, right? We don't always know what to do the first time. What I remember was that the person with the lowest number gets to choose the song. We were told that her friends have already rolled a 6, 5, and a 2. We're rolling a number cube, which I know has 6 total possibilities. And she needs to do the lowest. Well, I'm looking at these and I'm thinking 1 is the only number less than 2, and if she has to get the lowest, she has to get a 1. So the probability of her getting a 1 on a dice, 1 is only one of the numbers, that's 1 out of 6. So she has a 1/6 chance of rolling the dice at random and getting a 1 to be able to choose the song. All right, another random events. So again, this is just meaning something, we're picking something out of our choices, finding the probability. The table here shows the number of brass instruments players in the New York Philharmonic. Suppose one brass instrument player is randomly selected to be a featured performer. Find the probability of each event, and then write each fraction in simplest form. So looking here is my information. Well, to be able to figure out, so I look here, and I'm looking at D, and I'm looking for the probability of getting a trumpet. So I look and I see that there are 3 favorable trumpets. So that's my numerator. But I need to know the total possible. So what I'm going to have to do is figure out all of the players. I'm going to have to add up all of these. So then I have 10, 13, 14 total. So that's important for me to know my total possible. So then I get 3 out of 14. 3 and 14 don't share any factors. So the probability of selecting a trumpet player is 3 out of 14. For E, the probability of selecting a brass instrument player. So, we have to know some information here. Little prior knowledge is necessary here. That's a brass instrument. Well, all of these happen to be brass instruments. So that means that we have a 14 out of 14 chance, which is 100%, which it is certain that I'm going to pick a player of a brass instrument because that is what I'm drawing from. Similarly, yet different, we have the probability of selecting someone with a flute. Well, are there any flute players on this list? No. So that's a 0 out of 14. That is a 0% chance or an impossible selection. You can't pick a flute player. Lastly, we're going to pick the probability of a horn or a tuba player. Again, we are out of 14, but now we're including the horn and the tuba. Horn, there are 6. Tuba, there's 1, so that's a total of 7, which then will simplify to 1/2 or a 50% chance. So 1/2 chance of picking either of those instruments. Directions. The directions said to answer fraction simplest form. I got so excited and I did percents. So it would be important to know 0 over 14 would simplify to 0. 14 over 14 simplifies to 1. Okay, so this is kind of a funny little thing here, but it's important. So complementary event. This is finding pretty much what will not happen. So what is the probability that an event will not occur? And this little study tip here is super helpful. So if you want to write some of this down. So we write things as something not happening, the event. What we know is that you either have, the probability can only be 100%. Something's going to happen or it's not going to happen. It's going to rain or it's not going to rain. And so on this spinner here, as you can see, it's 1 through 6. I'm going to get a 6 or I'm not going to get a 6. Right? Things are either yes or no. So probability is always going to go up to 1 or 100%. So you can do some adding. The likelihood that an event will happen and not happen will be 1. So Ramon's teacher is using this spinner similar to the one we see, and we are going to figure out the probability for each event and then write it as a fraction in simplest form. So again, you can do a couple ways. Looking at this, we have a spinner 1 through 6, and they're all equal parts. So that means that the probability of not getting a 4, okay, so thinking if I don't get a 4, if there are 6 outcomes and I don't get a 4, which is one of the choices, I'm going to be left with 5 other choices. So my probability of not getting a 4 would be 5 of the 6. Because then again, think, if the probability of me getting a 4 is 1 out of 6, notice 5, 6 plus 1, 6, I have 1 whole, all of the choices are accounted for. Likely, on the other side, probability of not being in group 1 or group 3. Well, if there's 6 choices and we take 2 of them out, that means the probability of not being in 1 or 3, that means there are 4 other choices left. That's 4 out of the 6, which is the same as 2/3, more likely. And again, to make sure that you understand kind of the complement here, is that the probability that I would be in 1 or 3, so the complement to the event, right, making up the whole, not 1 or 3 is 2/3. Well, being in 1 or 3 are 2 of the 6 groups, which simplifies to 1/3. Notice 2/3 and 1/3 would equal 1 whole. So understanding that the likelihood that it will and will not happen are going to get up to 1. Okay, so testing out some at random probability. I have a deck of cards here and some information you probably need to know in case you don't. A deck of cards is 52 total cards. There are 4 suits, clubs, spades, diamonds, and hearts, and each suit has 13 cards, ace through king. So if I'm playing cards with Buddy here, because he likes magic tricks, and we have a whole box of cards, I'm wondering what is the probability that Buddy is going to select a red 2. So I think, okay, there's 4 suits. All of them have 1 through 13. So that means all of them are going to have a 2. So I'm thinking, okay, there's 4 2s out of the 52. But only 2 of the suits are red. So that means there are 2 total 2 red cards. I said 2 too many times. But so the probability that Buddy's going to get a red 2. Let me think about that. 2 out of 52. And then you simplify. So 1/26. Buddy, can you do it? Pick a card, Buddy. This one. It was red, but it wasn't 2. Okay, well, Buddy's luck wasn't favorable. That's all right. We know the probability now. So I would love it if you gave these options a try. With that situation of Buddy drawing from a deck, what would the probability of him getting a black even card be? So it has to be both black and even. What would the probability, now complementary event, of it not being red? And what would the probability of him getting a face card? Face card meaning a jack, queen, or king. So in that situation, try to see if you can figure out those probabilities, and we will have you submit those, and we'll talk about the results. Good luck. Keep doing your best. Yeehaw.